In this video, we're going to continue our discussion on SQL injection. Specifically, we're going to look at blind SQL injection. So on the left here, we have a customer search form where we can type in a customer's ID and submit it. And then on the back end, we have this query that's going to check to see if that customer ID exists and return the name, street, city, state, and zip code. The problem here is that we're putting the post of the customer ID right inside of the query that opens us up to SQL injection. So a normal query would look like this, where you type in 101 and it's going to return the results for that specific customer. However, with the blind SQL query, we can find out additional information that maybe we don't have privy to or that we shouldn't have access to. For example, through trial and error, I could put an additional criteria using AND with that original criteria. And if I get results, then I know the condition is true for both of them. And if I don't get results, then I know the condition is not true. So for example, I say 101 and then we're going to select the pin from customer where, and then I have a substring here. So what this substring is doing is grabbing the last 4 digits of credit card number. Let's say, for example, I knew the customer's last 4 digits, and then it's going to compare this against those 4 digits that I know. And then it will grab the pin if the last 4 digits matches the credit card number of the customer. And if that pin is greater than 2000, it's going to return results. Then I can run this query again, but this time I'm going to check to see if the pin is greater than 3000. And if there's no results, I can keep trying this like 2500. And if there's no results, I know that the pin is less than 2500. And then I'll try 2250. And if there's results, I know it's greater. And eventually I keep running this until I know that the pin is actually 2284. Since there were results when the number was greater than 2283 and no results when the number was greater than 2284, I know that the pin is 2284. So what I want you to do is try this learning activity. So go to the SQL injection section, open the blind SQL injection page, and then use a blind SQL injection to determine the correct CVV. So pause this video, try this on your own, and then come back to compare your answer. All right, welcome back. So you'll notice here that it's asking me to enter a credit card number, and I'm going to use this to try to figure out the CVV. So I'm going to go ahead and just copy this credit card number and paste it here. And then I'm going to do an AND where the CVV is greater than 500 because we know the CVV is only 3 digits. I'll go ahead and copy this so I can keep running this and changing the number. So I'll submit it, and we know that the CVV is valid but not exact. And the reason why we know it's valid is because it returned results. So let's go ahead and change this to 750. So I'll go ahead and click submit, and we know that the CV is invalid because no customers were returned. So I'll go ahead and try this again, and I'm going to try 650. And we know it's valid because it returned a number. And I already know the number, so I'm going to go ahead and try where the CVV is greater than 651, but you could keep trying this by bouncing back and forth. And you'll notice that the CVV is invalid. So we know that it's greater than 650, but not greater than 651. So our answer here is 651. I'm just going to go ahead and submit 651 as our CVV. And you'll notice that we successfully entered the correct CVV for the associated credit card number. So there are additional SQL injections that you can perform against a database, and they are shown here. For example, you can do string concatenation, where you use quotes or a combination of anding and ors to be able to get information that you want. For example, this first one in the password field, if I type quote or quote one, quote equals quote one, it's going to basically do what we did before. For the second one, if I put a quote in for the username, it's going to cancel out that second quote, making it interpret it as a literal quote instead of a continuation of the SQL string. And so it's going to be the username is equal to quote and password equals. And then I can just say or 1 equals 1. I can also use other things other than 1 equals 1. I could do or A equals A. With line comments, we showed you this, but I could put admin quote # as the username to cancel out the password. You can also do a line comment with a dash space, which you see on the next line. You can also use like a backslash to change the quote from a continuation of the SQL string to a literal quote. And so that means that the username is going to be quote and password equals. And then I can continue my SQL string with or 2 is greater than 1, and then the # to comment out the quote. So when is 2 greater than 1? Always, so it's going to return all the users. You could also do a block comment SQL injection. For example, if the database inserts into the user table the columns username, privilege, and password, I could pass the values of attacker quote, comma, quote, admin quote, comma, /* as the username. And the slash star is going to start a block comment. And then for the privilege, that's going to be automatic, and it's going to be the student that you see in gray text here. And then for the password, I could type in */ compromised. And what that's going to do is it's going to comment out the student part and use attacker for the username, admin for the privilege, and compromise for the password. I can do query chaining, which we talked about, where I just add a semicolon. And in this case, I add a quote before the semicolon because I'm dealing with a string, and then delete from users. You could also incorporate unions to be able to find out more information. For example, I can first discover the total number of columns via trial and error by using order by. So I say select star from course where the course ID equals 1, and then order by 6. And if I get results, we know that there are at least 6 columns that are returned. And then I could do 7. And if it fails, we know that 7 columns aren't returned. So I want to concoct a query that is going to use union to return 6 columns. So in this case, I'm going to say select star from course where the course ID equals 1 and 1 equals 2. So 1 never equals 2, so it's going to completely invalidate that first query and ignore it altogether. And the union is going to allow me then to append a second query to it. So I say union select username password 3456 from users. So that's going to return the username, password, and just the numbers 3456 to match the same 6 columns that were returned in the original query. And since it's looking for 6 columns, it's going to find those and it's going to return them here. And now I have access to the username and the password. Hopefully, at least the passwords were encrypted if they're still open to SQL injection. Finally, you can run SQL queries using subqueries. For example, here, if I say select star from event where event ID equals 1, normally that's going to return the event where the event ID equals 1. But if I add at the end and select distinct 1 from account and set that equal to 1, what that's going to do, if the result is returned, we know that the table name of account exists in our database. So as an example of a SQL injection that actually happened, I was filling out a survey for Schmidt Music, and I typed a quote in the survey. I said something along the lines of, "I can't." And I got this error message back, which made me know that they were open to SQL injections. So I thought about performing a SQL injection and then quickly realized the legality of it, and I did not want to get in trouble. And so instead, what I did is I went back to the form and I submitted, hey, you're vulnerable to SQL injection, and here are a few resources that you should look at to fix your error. And I left it at that. And then a few months later, I decided to test this form again, and I typed in can't, and I didn't get an error message. And I was pleased to know that they might have implemented the guidance that I gave them. Now I just need to collect my consulting fee from them. Thanks for watching my video. Feel free to click the links here to watch the next video of the playlist, continue to the next playlist, or subscribe.